Hello everyone, the Humble Math Tutor here. Welcome back to the channel and welcome to this video on special trig triangles. There are two special triangles you must know by heart, and they can be derived easily. Let's have a look. To construct the first of the two special triangles, draw a 45-degree angle. Pretend that you are, for example, connecting the lower left vertex of a square to the upper right vertex. Something like that. Draw the triangle like this by putting in the horizontal side and the vertical side. That creates a 90-degree angle here, and this is a 45-degree angle. That would imply that this side is the same length as this side. Let's just call them 1 and 1 for now. This side will be r, the hypotenuse, and by Pythagoras, r squared equals 1 squared plus 1 squared. R squared will then be 1 plus 1. R squared will be 2, and r will be root 2. Next, let's label the sides of this triangle using opposite, adjacent, and hypotenuse as our labels. This will be the adjacent side, because adjacent means beside, and this side is beside the 45-degree angle. This is the opposite side because it's on the farthest side of the triangle compared to our angle 45 degrees. And this will be the hypotenuse. Remember, r is root 2. I'll just put a root 2 there. Now we can say that sine of 45 degrees is opposite over hypotenuse, which is 1 over root 2. Cos of 45 degrees is adjacent over hypotenuse, which is 1 over root 2. And the tangent of 45 degrees is opposite over adjacent, which is 1 over 1, which is also 1. Now these are exact values. We didn't reach for a calculator and press this and compute that to some decimal approximation. That's a precise value. Now your teacher may insist that the denominator be rationalized. So to do that, you would multiply top and bottom by root 2. And that would give you root 2 over 2. This is a perfectly good value for the sine of 45 degrees, but your teacher may insist you use this one. Just follow your teacher's lead on that. Same thing for this guy. Multiply top and bottom by root 2. And for the cos of 45, you get this alternative version, root 2 over 2. And tan 45 is just 1. So these values have to be memorized by you. Now, to compute the other special triangle, you would do this. Create an equilateral triangle where each side is 2 units long. So equilateral means every angle is 60 degrees in every corner. This would be 2 units long, this is 2 units long, this is 60 degrees, this is 60 degrees, this is 60 degrees. Then you drop a perpendicular down, splitting the base in half, making this one and this one, and that's 90 degrees. Now, inside this triangle, that's our triangle of interest. This side is unknown. Let's just call it h for now, and use Pythagoras. The sum of the squares of the shorter sides will be the hypotenuse squared. So h squared plus 1 squared will be 2 squared. H squared plus 1 will be 4. Subtract 1 from each side, and h squared will be 3. H will be the square root of 3. Now what we should do is just take this triangle and just break it away from the larger picture so that we can do our computations. Or I'm just going to take this guy here, now that I know all the side lengths, and redraw him on the next page. So let's just do that here. So now I know this is a special triangle. This is 60 degrees. This is a right angle. This is 2, this is root 3, and this is 1. From the viewpoint of this angle, let's label the sides. This would be the hypotenuse. This would be the adjacent side. Remember, adjacent means beside, and this side of length 1 is beside the 60-degree angle. And this is the opposite side. So now what I can do is write out sine, cos, and tan. So the sine of 60 degrees will be opposite over a hypotenuse, which is root 3 over 2. The cos of 60 degrees will be adjacent over hypotenuse, which is 1 over 2. And the tangent of 60 degrees will be opposite over adjacent, which is root 3 over 1, which is root 3. Now, I've said before, you need to memorize these values, but if you use them frequently enough, they tend to stick with you. They tend to stick with you. You will remember them. Now, notice we've left this angle conspicuously blank. There's a 30-degree angle there, because the angles inside a triangle add to 180. This would be 30 degrees, wouldn't it? So that gives us access to sine and cos and tan of 30 degrees as well. So here we'll do that. So we recreate our special triangle with the same side lengths. And now I'll put 30 degrees here, and we will relabel the sides according to opposite, adjacent, and hypotenuse from the viewpoint of the 30-degree angle this time. Well, the longest side is always the hypotenuse. This time the 1 is the opposite side, and this will be the adjacent side. Adjacent means beside, and it is beside the 30-degree angle. And now I can say that the sine of 30 degrees is opposite over hypotenuse, which is 1/2. The cos of 30 degrees is adjacent over hypotenuse, which is root 3 over 2. And the tangent of 30 degrees is opposite over adjacent, which is 1 over root 3. A perfectly acceptable exact value, but your teacher again may insist that you rationalize the denominator. Follow your teacher's lead on that, giving you another version of root 3 over 3. It's the same numerical value as that one, but use this if your teacher directs you to. What's the most common application of this knowledge? The most common application is to do questions like this. Evaluate the tangent, for example, of 210 degrees. Would be a good sample question. To do that, you migrate this information into an analytic setting, and that's just math, fancy speak for on the xy plane. If you're on the xy plane, you're measuring your angles measured counterclockwise from the positive portion of the x-axis. This would be 90 degrees. This would be 180 degrees. Adding another 90 degrees gives you 270 degrees, and finally 360 degrees. Well, to evaluate the tangent of 210 degrees, you should locate 210 degrees on the xy plane. 210, you'll notice it's 30 degrees beyond 180. The difference between 210 and 180 is 30 degrees. That's also known as your reference angle. So that means you'd be looking at an angle about like that. You don't have to draw it absolutely precisely, but this is 210 degrees because you're 30 degrees beyond 180. But your special triangle kicks in now, doesn't it? Your special triangle kicks in because that's a 30-degree angle. And there's your special triangle right there. That's a 30, this is 60, and this is a 1, 2, root 3 triangle. Except that you're moving left from the origin, meaning your x value would be negative, and you're moving down from the x-axis, meaning your y value would be negative. So in this analytic setting, these side lengths do take on these negative characteristics depending on what quadrant you're in. But now I can compute the tangent of 210 degrees because this would be the opposite side and this would be the adjacent side. So here I've got an opposite side here and an adjacent side here. I don't need to label the hypotenuse. It's not needed for the calculation. I can just simply say that the tangent of 210 degrees has this precise value, -1 over negative root 3. And two negatives divide to a positive, and that gives you 1 over root 3. And there we are. If you enjoyed this video, please like, subscribe, and share. Thank you so much for watching.